Hi guys, this is Ableton Bible, and in this session we're going to be going through the last few aspects of bass processing and mixing. So in the last session we looked at EQ and how we can move things out of the way of each other in the frequency domain. So in this one we're going to look a little bit more in the time domain and how we can use things such as sidechain compression as well as other types of compression. And then we're just going to finish off with a little bit of bus processing. So I did cover sidechaining in one of the earlier videos when we were doing the techno synthesis, but fundamentally all we're doing when we're sidechaining is we're moving things out of the way of each other in the time domain dependent on the aspect that we're sidechaining to. So for sidechaining a kick, then the bass is going to move out of the way of that kick, but only while the kick sounds, and then it's going to go back to its normal state. So that means that it's not going to be affected when the kick isn't hitting. And with sidechaining we can sidechain loads of different things like gates, compressors and EQ. So dynamic EQ is quite a good one to do, so that's just going to make an EQ cut at a specific time, or an EQ boost if we wanted to. And the other type of sidechain that's most commonly used is sidechain compression, which is exactly the same as it would be with EQ, but rather than notching the signal out, it's going to compress it. So what I'm going to do now is just play this track, and we're going to hear where we can maybe benefit from using the sidechain. So if we go into the MIDI, then this is going to be a lot more clear. So as we can see in this bar measure, we've got note 2, also a bit of note 1 and note 3, which has the kick and the bass hitting at the same time. So this would be well worth having a bit of sidechain compression or sidechain EQ on it. So there's loads of different ways we can do it. I'll just show you a few different types. So I think we'll start off with the LFO tool. So we'll just load up this LFO tool onto our bass track, and we can see we've got our envelope here, which can be assignable. And if we play this, we can just change the shape slightly so we get rid of that clicky sound. So if you listen, it doesn't sound very good, so we'll just nudge that back a bit. And we can choose from all of these different shapes. These can be set as the modulation envelope for all of these different parameters, and you can see that modulated now on the right hand side by the little blue dot. And we can just customize this shape just by dragging these nodes around. We can also change the curve in between the nodes, and we can add extra nodes as well. So it's a really diverse plugin, and one I'd highly recommend as it's not very expensive either. So next up we've got the Kickstart plugin, and Kickstart is brilliant because it's nice and simple to set up. It's a little bit more restrictive than LFO tool in capability. However, that's not always what you want. You just want to really quickly dial in a set envelope. So if it's a standard kick side chain, that's perfect because you're not going to need any more shapes than this. And then all it's got is a dry wet knob, and you can also change the cycle speed of this LFO as well in the top left, so you can change it between an eighth note, quarter note, half note, or a full note that it repeats this LFO. So on this sort of envelope setting, we're not going to let any of the first part of the signal through depending on the cycle time we've got. And I do like this plugin, but I do find it can be a little bit clicky sometimes. And if we look here, we can see at eighth notes, at each one of these markers is where it's going to be cutting the signal. And at 100%, it's not going to let any signal through. It's going to be like a tremolo effect at these positions. So what we'll do is we'll leave this on quarter notes, and we're going to move it back down to about 50% so it's not so prominent. And then we're going to leave that sidechaining on this bass part. And we'll now move over to our next bass, and we'll have a little bit of a listen. So if we look at the MIDI, we can get some clues as to what's going on. And once again, we've got a similar situation here on 1, 2 and 4. So rather than using LFO tool or Kickstart, what we're going to do is we're going to use some standard automation. So the quickest way of doing the volume automation within a clip is to go down to the clip envelope, and what we can do is just select the mixer, and then on the next drop down we can set the track volume, and this gives us the automation on this clip for the track volume. So this is quite useful because the automation is specific to this clip. However, a problem with this is that it does leave messy automation on our track's volume fader, and when we're trying to mix down tracks, that's not really what we want because it means we can't adjust the faders without messing with the automation. So a better way of doing that is to do exactly what we've just done, but to use a utility plugin instead and to automate the gain. Or we can modulate the gain, and there's quite a big difference between the two because modulation is relative and automation is absolute. So what that means is, if we try and change the automation position, or the position of the fader or knob, then it's going to turn the automation off. However, if we try and do this with modulation, then the modulation is still going to happen, and it's going to happen relative to the new fader position. So I'd say, if you can help it, try and use modulation, because it's a lot more useful, especially when you're going to be changing parameters and tweaking them, and in a live environment. So for now, I'm just going to show you the automation on the utility plugin. So what we can do is just copy this envelope and then paste it across. So we're using Command C and Command V, copy and paste. Or we could paste it by right clicking, and we can just hold down the Alt key and we can change these curves. And this will make a drastic difference to the sound, especially with something like volume automation. And we could also do this with something like a filter cutoff. It's completely up to you how you want to do it and what device you want to use. So you can just hear that in action. And we can also see it with this little red dot, so we can see that this is automation and not modulation. So what we can do is just go into this automation and clear the envelope, or clear the automation. And now we can go show modulation, and what this is showing us is the relative parameter position down to 0. So we'll just set another automation curve and copy and paste that across. And now you can think of the top of this clip as being wherever we decide to set our parameter to. So I'm just going to add this in so we don't get a click. Just have to get rid of the extra node. And if we switch back to session view, you can now see how this is different to automation. So we don't get a dot, we just get this little orange modulation happening. So now we can set this parameter and tweak it while still having the modulation take effect. So now we're going to take a look at something that I imagine you're all going to be a lot more familiar with, which is bog standard sidechain compression using a compressor. So we'll do this with a different track. We'll do it with this bass. And I'm just going to load a compressor up so we can have a look at the settings. So we could load up a glue compressor or the bog standard compressor, it doesn't really matter. I'll just go for this normal one. And we'll drop it on, and I don't want to teach you to suck eggs too much here. So it's fairly standard stuff. We'll just go to sidechain and select audio from, and this is going to be our sidechain input. So we want to take it from the kick on beat 4. Hold on, that's actually the group, so I just need to change that. We need the kick from beat 4, not the whole beat, because otherwise it's going to be sidechaining every single hit of that beat. So let's just have a look for kick, and it should be, there we go, underneath beat 4. So we'll select that, and now we've got our sidechain, and we can see that in the gain reduction meter on every quarter note. So now we can dive into the settings and get them a bit more suitable for sidechaining. So we're going to pull this knee right down, so it's a very abrupt type of compressor. We can go into the transfer curve view and bring the look ahead forward slightly, so now the compressor's looking ahead of the beat and kicking in ever so slightly earlier than it should be. And this is giving it a bit more time to react and make sure that it ducks in time for that transient. And peak mode is good for drums, so I'm going to turn it on to peak mode and turn the ratio up. And we can pull the threshold down, and we can see we've got lots of gain reduction happening now, indicated in the gain reduction meter, this yellow bar. But we need this to have time to go back to 0, because otherwise if it's under constant gain reduction, we might as well just turn the volume down or turn the volume up. It's not going to be doing a great deal. So we need to see a rate of change happening in this gain reduction meter for a good amount of compression. So give it time to get back to 0, and if you're not sure, then put auto release on, because what this will do is it will set the release parameter dependent on the duration of the audio coming into the compressor. So if we have any clicks and pops, we can get rid of those with a low pass filter, but I'd only use this on bass because otherwise you're going to really mess up the sound. And what we can also do, another few ways of setting up sidechain compressors or to do sidechaining is to use a independent sidechain trigger. So you'll see this technique getting used quite a lot. We'll just rename it and change the colour for good housekeeping. And what some people do is they'll put an instrument on this, such as a simpler, and they'll load in a really short sample, so they've got a really nice tight sidechain trigger, and then they'll draw in some MIDI throughout the whole length of their track. So this is really useful if you want to sidechain things like pads or whatever, because you're not going to have a kick drum in the breakdown. So your sidechain is going to stop working during that breakdown. But if you do it like this, then you're not going to have that problem. So let's just go through and choose a sample now. It doesn't really matter what you choose because you can shorten the decay using simpler. So I'll just pull this sustain down. So now what we can do is go to our input-output routing, and we can select from the MIDI from, we can change this to our kick, and this means that we have a lot more control over our sidechain trigger without affecting our actual kick in the mix. So just be aware, this is going to be a kick type sidechain. It's not going to work with pads and stuff when there's no kick sounding, but we can use the track delay now to adjust the flavour of our sidechain by nudging it forward or backward of the beat to give it a rushed or a lazy feel. So at the moment, you've probably noticed we can actually hear our sidechain trigger, which isn't what we want. So we go to Audio 2 and change that from master to sends only. So now it's only going to go to our sidechain, and all we need to do is go back to our bass and select this sidechain trigger from the sidechain menu in the compressor. Okay guys, so now we're going to take a little bit of a look at compression. So the main purpose for compression is to even out the dynamics of a sound and to try and reduce the dynamic range, and usually that's in order to add extra loudness to the signal. So there's also a few other secondary things we can do, like we can emphasize and shape the sound. So we might want to emphasize the pluck of a bass, or we might want to soften the pluck of a bass and make it more well-rounded. And these are all things we can do with compression dependent on the compressor's settings. So before we dive into compression and start trying to fix problems that aren't there, or to level out the dynamic range, we need to think to ourselves, can we sort out the problem, or can we achieve the results we're after by going back into our synthesizer and altering things like the filter and the amp envelopes, because a lot of the time it's a much better way to do it instead of over processing a signal. So if we want to go for a bit more of a plucky attack, a good way of doing this is to have the attack set slower. So now this signal is going to take 31 milliseconds to go from uncompressed to fully compressed as per set by the threshold level. So we'll set this ratio to 5 so it's easier to hear. And every single time the threshold is crossed, the compressor is going to slowly start to reduce the gain until it reaches the maximum gain reduction after 31 milliseconds. And we can see that in the metering here. And if we go to activity view and we tighten up the attack time, we can see this yellow line gets a lot more instantaneous and aggressive, as we'd expect, because we've got a much shorter attack, so the compression is happening much faster. So then we've also got the release as well. So the attack and release are going to work in conjunction with each other, and they're going to set the sort of shape of the compression and how the compressor is going to work. So with the release parameter, if we slow this right the way down, we'll see the gain reduction meter also slowing down until it's under constant gain reduction. And if we speed this back up again, we're going to get a much faster and jumpier type of gain reduction. And what this can sometimes do is give us a distortion with fast release times, as it's reacting on a cycle basis. And this is also the same for the attack as well. And likewise, if we have the attack really fast, then what we're going to be doing is the opposite. We're going to be completely squashing the peaks. So this is basically acting like a limiter in this position. It'll be quite a noisy one, but that'll be limiting the signal because it's not going to let any of the peak through. And as we slow down the attack, we're going to be slowly letting a little bit more of the peak through, and it's going to sound a bit more natural. And another way of doing this is just switching to RMS mode. So it's going to react on averages at the input rather than peaks at the input. So that's what RMS does, or root mean squared. So generally speaking, RMS tends to be a bit more of a smoother and less noticeable compression. So we can also soften the compression using the knee function. So as we bring this up, it's going to smooth out the knee. So this just means that compression happens prior to hitting the threshold. so this can work quite nicely to smooth basses out if the compression is sounding a bit too abrupt. So the best way to set a compressor, in my opinion, would be to set the ratio to about 5:1 first, because that's enough compression that you're going to be able to hear what's going on, and then pull the threshold down so you can see a bit of gain reduction happening in the meters, just so you can actually hear the compression. Then set your attack and release to whatever desired setting you want. So this might be to let the transients in, it might be a slightly tighter and more well-rounded compression, a little bit more control, but beware of distortion at lower values. And then you can also set your release, and it's the same with the release. Faster settings tend to be more energetic, and you can see the gain reduction happening, so you tend to want to make sure that it's got time to reset to 0, and at tighter settings you may get distortion. And then we can go ahead and change the ratio and the threshold to something a little bit more sensible or more dramatic, and we can also start thinking about things like the compressor modes such as peak or RMS, and the knee setting as well. So for those of you that don't know much about compression, just to really quickly cover, we've got the attack and release, which combined are very important settings, but so is the ratio and the threshold. So if we set the ratio so it's at its highest setting, and then we have the threshold so it's just clipping the top peaks, what this is going to do is it's going to limit the highest peaks, the highest transients of the audio, so it's going to completely squash them down. Whereas if we have the ratio set really low, then it's only ever so slightly going to reduce the dynamic range, but it's only going to reduce the dynamic range of those very highest peaks. Whereas if we have the ratio set really high, and we also set the threshold really low, then it's going to limit the whole signal, so it's going to absolutely squash the entirety of the signal. Whereas if we have that threshold set low, and we have the ratio set low, then it's going to gently massage the entire signal and reduce it in dynamic range, but not too wildly, so we're still going to have some decent amount of dynamics in the signal. So those are the four sort of main extreme variables that we can have, and anything else is going to be a variation of that in between those four main extremes. Okay guys, now we're going to talk a little bit about distortion, so it would be fitting to do that with the 303. So I'm just going to set this to low frequency mode. And we've already built in a bit of distortion into this plugin by using the macro controls with the overdrive and the shaper drive macros. So I'm just going to close that down now, but I'm going to show you what that controls just by giving it a little twiddle while we're playing the track, so you can actually hear how that affects the signal and what happens in the spectrum analyzer. So we can instantly see here, when we've got these two macros turned right down, we've got a little bit of distortion still, but we haven't got anything too crazy. And the reason we still got a bit of distortion is because I programmed it using a different shaper within the actual device. But as we add this drive, you're going to see the extra harmonics creep in. We're going to get a bit more weight up in that top end, up in the sort of 1 to 10 kilohertz region. Just start to see it creeping in there. And now, as we play this in the context of our drums or within our mix, it's going to make it a lot clearer to be able to hear what's going on with this acid over the top of the drums. It's going to really help it fight through the mix, because what it's going to be doing is it's going to be taking up more presence in that 1 to 10 kilohertz region where we've got a lot more space, so it's going to be a lot easier for us to hear it. And if you watch closely in the spectrum analyzer and on the levels, you'll see that whilst we are adding harmonics, we're not actually adding a great deal of level to the entire track as a whole. And that's because of the way distortion or clipping works. What it's actually doing is it's, in a way, squashing and compressing the signal slightly, and that's what's producing these extra harmonics. So this will add a bit of level, but it's a much better way of getting presence into the signal without having to boost the gain too much. So if you want to get your head around this, then the best way to think of it is with something like white noise, which is equal amplitude and it's every single frequency present in the spectrum. So if you think about that, nothing is going to mask that sound, it's always going to be easily heard. So what we're doing with distortion is we're pushing up harmonics and we're making a lot more frequency content. So the more frequencies we have at higher amplitude, the easier they're going to be to hear in the mix. So I'm just going to flick through some of these basses and listen for one that could do with a little bit of saturation or distortion to stand out a little bit more. So it'll probably be one of these techno ones. I think I'll go for this one. And funnily enough, this is actually a technique that's used quite a lot in techno on the kick drum to make the kick drum stick out from the sub bass. Loads of distortion. So this has already got quite a lot on it, but I'm just going to put even more on for the sake of the demonstration, just to show you. And then what we'll do is we'll set up a little macro control and we'll do an A/B. So I'm just going to bring over the spectrum analyzer from this acid bass. So I'll just drag and drop that. So we'll just set the drive to macro 1. And we'll set the output to macro 1 as well. And we just need to go into the mapping and have a little mess around with these controls so that we're slightly reducing the output as we increase the saturation. And that's going to stop us from being biased and thinking that it's standing out more purely because we've actually boosted the gain slightly or boosted the drive slightly. And this is also a very common problem with compression as well, so something to be aware of. When you A/B, you must get those relative levels as close as you can using your ear. So clearly this is way too much, and we can see the shift in the spectrum analyzer as we crank up macro 1. And we can also flick through some of the saturation types, and we'll see how that affects the signal. And if we're doing this in a parallel configuration, you'll actually be surprised just how much we can get away with, and some pretty radical settings mixed in at low volumes can work wonders. So we'll just do a little A/B comparison of that. And I think that works really nicely, and you can hear it make the bass pop out. So now I'm going to show you some bus processing and some routing options. So I'm going to do this using this guitar track that I've swapped out from one of the basses, just because this is a plucked bass guitar, so it's a little bit more dynamic, so it's going to be easier to hear what's going on when we start doing the parallel type processing. And we're going to start off by making ourselves a bus, which is like an auxiliary bus. So we just think about this as a bit like a return track. We can just route things in and out of it, so we can send multiple tracks to this bus. So if we go to our bass 3 and we go to the audio 2, then we can change this to bus, and we can do the same for beat 3. Okay, so what that now means is that it's going from bass 3 to bus and then to the master, and then it's going from beat 3 to the bus and then to the master. And you'll notice we can't hear that, so we need to go to input output and change the monitor to in. So that's now basically made this bus a group or a auxiliary channel. So all it's doing is allowing us to process beat 3 and bass 3 at the same time. So obviously we can't group those two because they're already grouped, so this is why we'd use the bus. So the advantage of using this bus is it means we can treat these two tracks, bass 3 and beat 3, together, and doing that is going to make them sound a lot more unified and glued and cohesive in the mix. And this bass sound is quite picky, so what we can do is we can think about maybe doing some parallel compression. So to do parallel compression, it would be as simple as we use a glue compressor. All we do is set our parallel settings, and then we set this to 50%, and that will be the same as parallel compression. So you hear that really stomping on that signal. And now that we've got that nice strong compression, what we can do is set this back to 50%, so it's New York or parallel compression. So the more preferred and controlled way of doing parallel compression, at least for me, is to duplicate the chains and have a task for each chain. So in this case we've got compression, we have saturation, and then we might have distortion or a dry signal, and then we can just mix these accordingly using this device rack. So remember, when you are using a rack like this, to set all the devices to 100% wet, because you are going to be using the dry chain to mix the dry volume back in, so there's no need to have any dry level on the compression or saturation chains. So with the makeup gain, just add a decent amount, but don't worry too much because we can make the adjustments using the chain volume. So now we'll go to the saturation chain and just delete that glue compressor, replace it with a saturator, and we'll start setting the saturator settings. And like I said earlier, you can use some pretty harsh settings because you're not actually going to hear this in solo, it's only going to be heard in context when we've mixed it in to the rest of this track. And we're going to have the dry signal in as well, and the saturation and compression will be at fairly low values, so it can be pretty nasty compression and saturation. And as for the dry signal, that's just going to be left dry. So in our normal fashion, we're just going to set all these to our macro controls and rename them. And this is quite a good thing to do if you want to use a MIDI controller. You can map the MIDI controllers to these macro controls, and it's just a bit better for playing the mix. So when you're finalising your mix, recording this sort of stuff in tiny little micro changes is really going to make a difference and make your track sound a bit more dynamic and fluid and interesting. So now we can just go about setting the levels of these three devices or these three chains, and we can use the command function if we want to fine tune in smaller increments. And we need to really pay attention to the output gain of this track when we're doing this, because when we do A/B comparisons using this bypass button, we want to be making unbiased opinions and decisions. So we can click the reset button on the bus, and that will tell us the highest peak at any one time, so we can set this as accurately as possible. So as you can hear and see on the meters, it's actually peaking when we've got the effect turned off, and when we turn it on, it's balancing out the signal more, compressing it, making it a lot more weighty, and adding a lot more harmonics, so it's a lot easier to hear. So if we just reset this meter, we can now see it's not clipping with this effect on, and it sounds much better. So this is why parallel processing is such a powerful tool. So the next logical step with parallel processing is actually to channel the parallel processing exactly where we want it to be. So with the saturation, we might want to only saturate a certain EQ band. So what we can do is we can use some shelving EQ just before the saturation in this band, and we can channel it so it's only going to affect the mid-range. So with this parallel processing, I'm using shelving EQ because the last thing I want to do is start adding any sort of phase or timing changes. So when this blends with the rest of the signal, it might be causing phase issues. So the best way to stop that is just to be gentle with the curves you use and try not to use any plugins that are going to add a latency. Personally, I actually like this saturation on the entirety of the signal rather than just this single EQ band, but it's still a good little thing to know, especially for things like reverbs on higher parts with parallel processing, or compression, or a combination of any of these devices together. So we've now come to the end of the electronic music production base course. I hope you've all found the course useful and that you can take away some of the theory from this and use it in your own productions. Towards the end of the course, we've gone into some pretty advanced techniques, so if there's anything you don't understand, then make sure you check out all of our free content on YouTube and on our website, which is available for download. And if you've still got any questions, or there's something that you want us to cover in one of our next videos, then just drop us an email at the address below. And make sure you either subscribe to our email list or keep checking back for our future releases over the coming months.